Hi. Today I want to get into something that I consider to be really one of the coolest things that's ever happened in the history of science. We just got done talking about Isaac Newton, right, and his discovery of the laws of motion and gravity and how orbits work. We're not done with Newton this school year. I mean, we're going to be getting back into Newtonian physics later on, but now I want to talk about the other guy that I mentioned. Newton would be for sure one of the top two scientists in the history of science. Now we're going to get into it. The other guy who's one of the top two scientists in scientific history. Um, it's a matter of personal preference, whether you think one was a greater science than the other. I'll tell you what, both of them were like giants in the history of science, okay? Isaac Newton, and the second one, whose name I know you know, this guy. Who is that? Say his name. Say his name. Says, if you said Albert Einstein, you are correct. Okay. So I want to get into a little bit of Einstein's theories, and we're going to hit him again later on too. So the title of this assignment is going to be Energy of the Sun. And will you please title your paper that? Now, if it's white, you got to write. Keep that in mind, okay? Anything written in white, you got to write down in your notes. This is the title of it. And that's where most of the questions will come from, and you can use it on a test. Anything written in yellow, you don't have to write down. Okay, I think you should know that by now. But here's the thing, is like, the sun is the energy source for Earth. It powers all life on Earth. Well, with the exception of some deep ocean trenches that have this other thing called chemosynthesis going on with sulfur compounds and stuff, which is a pretty recent discovery. But all the life on the surface of the Earth that you can walk around and see without having a deep ocean diving bell, its energy that drives it comes from the sun. Photosynthesis is the process plants have to capture that energy, and that enters the food chain, and then an animal comes along and eats the plant, and then something comes along and eats the animal. Maybe we eat a hamburger, whatever it is, but the energy ultimately comes from the sun. The weather is powered entirely by the sun. The sun is super important, that sunlight bathing the earth. Now, here's the thing. There's this thing called the law of conservation of energy, where energy is never created or destroyed. It only changes form. I'm not going to have you put that into the notes. I would like to. If we were in the classroom, we would have done that by now. But somebody's sending me a message if you keep hearing that ding. Okay, so where does the sun get its energy from? Right? The sun gets its energy from a process known as nuclear fusion. Okay? So here we go. Write this down. The sun's energy comes from a process called nuclear fusion. Now we're studying astronomy, which is like the study of the biggest things in the universe, the study of the universe itself, these vast distances and stuff. But to understand how it works, you have to get into the subatomic realm of what is matter made out of. So we're going to zip down into the atom to understand how this works. Nuclear fusion is the process. The sun doesn't burn like it, burning, combustion. You have wood in the presence of oxygen, and you have the self-sustaining chemical reaction, gives off energy. We call it burning. Sometimes they talk about the sun, the burning of the inside of the sun, but it's not fire. It's not combustion. It's nuclear fusion. There's no oxygen on the sun. There's no atmosphere. You couldn't have a fire there. It's not fire. What it is, and this again kind of gets into the whole concept of gravity and what we talked about with Isaac Newton. The gravity holds the planets in their orbit. It's also what holds the materials of the planets together. It's what holds the Earth together. It's what holds the sun together. But if you get enough gravitational pull, the sun is so big. Remember how big the sun is. If the sun is this big, the Earth is this big, right? It's huge. And there's so much crushing pressure of the gravitational pull in the center of the sun that the atoms themselves squeeze together until they lock, okay? The atoms themselves can't hold, the forces holding them apart separate, can't withstand that pressure, and they get squished together. nuclear fusion. The nuclei of the atoms, the nucleus, plural is nuclei, the nuclei of the atoms get squished together to where one element becomes another element. I don't know if you know the history of chemistry and stuff, the alchemists back in the olden days used to try to turn, lead into gold. We'll be rich if we can do that. And they couldn't do it. Transmogrification is what they called it. Can't do it. But in the sun, you can change one element to another. By these intense pressures, the atoms fuse together. The nuclear fusion is what it's called because you are fusing the nucleus. So that's what's going on to power the sun. Write that down, nuclear fusion. Test question. Okay, so here's a quickie thing here. The sun is made of mostly hydrogen. It's so huge it squeezes atoms together, causing their nuclei to fuse. The hydrogen turns into helium. You remember on the periodic table? There's hydrogen, helium, lithium, right? Okay, hydrogen's number 1, helium's number 2. So nuclear means in the nucleus of the atom, fusion means joined together, and it releases a lot of energy. That's where the energy comes from that powers the sun, that ends up radiating away from the sun in the form of light, electromagnetic radiation, and absorbed by the earth, and it heats the earth, and it powers life. It comes from nuclear fusion. Now, sunlight energy, a lot of people think that solar energy would be like the way of the future, so we aren't burning fossil fuels. That's an important one. Some people are thinking maybe nuclear fusion, if we could figure out a way to do that, that might be the ultimate answer to the human energy needs if you can figure out how to make that work. We'll get back to that at the end of the lesson. I think I'm going to stop this tape, answer a few questions, and we'll come back to the next segment.